All right then. So, hi viewers, hi class. So let's talk through some of the most important stuff of this chapter. So, like I mentioned last time, this specific chapter is quite important for general economics if you're going to choose it for your course package and do it in the coming 3 years. Um, Supply and demand. Let's go. Today, I want to teach you three things, and this is going to help you with the homework that you will need to do to understand the gist of it. So let's get cracking, okay? This is supply and demand, just a random model, okay? And you will need to practice this in your book, by the way, but I'm just going to show you the theoretic concept of it, okay? So you might remember from the last time that I talked you through this, that if you let markets have their way, what tends to happen is the following. Equilibrium is then achieved. Equilibrium. And equilibrium means evenwicht in Dutch. So supply and demand are the same at that moment. This is the supply line, this is the demand line. This is the equilibrium price, this is the equilibrium quantity. Okay, so this is the graphic concept, and what you also need to be able to understand is the formulas that go paired with it. Um, so we've practiced this last time. Formula for oh, sorry, this is A, this is Dutch. QS and QD, supply and demand curves. These are. Um, they both have a variable in the formula, and that's P. So P dictates the amount of supply or demand in this situation. And like I tried to explain last time, we only try to theorize one way as opposed to both ways, because you might suggest, for example, that the price is also dictated by the amount of supply or demand. But in this situation, we're only going to talk about the relationship between price and its effects on supply and demand. Okay, but you would make a valid point if you try to theorize the other way around. Uh, so by putting these two together and then solving them, for example, through the balancing method. I will show you in a minute, by the way, how to do this, because you might not have done this already. But by solving this equation, you would find the price P at which QS and QD are the same. QD are the same. The same. Okay. What I would like you to remember is, by solving this, you find the P at which QS and QD are the same. So you haven't found Q yet. So by inserting P at that moment, you would find Q. Let me show you how this works in a graphic sense. By making these two formulas the same, you're only finding PE, but you wouldn't have QE. So this is then still a question mark. Well, if you insert this in one of either formulas or in both even, they should give you the same answer. So let's just take some random examples of functions, okay? And then try to apply this method. And you will see how it goes then. Okay, let me find an example, okay? Should be simple enough to find one. Um, okay. Okay, so for example, yeah, I have here QD equals minus 0.2 P plus 6. Please notice, by the way, this is a negative because it's a minus sign. This is a negative relationship between price and demand. And with the supply curve, you will find it's the other way around. It basically says plus, um, wait, what is it here? Oh, yeah, plus 0.3 P minus 1.5, okay? This is a positive relationship between price and supply because suppliers want to receive a higher price for their supply. So let's put these two together then. The demand and the supply, they're both so intense. Put them together, it just makes sense, okay? Points for whoever knows where that reference is from. This is the balancing method. You've learned it during maths, okay? So I want to have all the p at one side plus 0.2 p. And also here then, I like to work with positive numbers, so I tend to get rid of the minus signs. Means that's 6 equals 0.5 p minus 1.5 plus 1.5 on both sides. Gives you then 7.5 equals 0.5 p. Let me have a quick look if you guys can still read this. Yeah, just splendidly, okay? And then obviously if 7.5 equals 0.5 p, then 7.5 divided by 0.5 should give you p. And in this case, I would assume that's 15. So the equilibrium price is 15 in this situation, but you still don't have what QE is then, and you just fill it in both formulas. And if you did this correctly, then it should give you the same answer for both QD and QS. If you didn't do it correctly, then you have different answers. So that's why you know you did things wrong. Well, let's have a look. 15 times minus 0.2, I think that's negative 3, plus 6 is positive 3, and plus 0.3p is 4.5, I think, and then minus 1.5 obviously means then that QE is 3. So like so. This is how to calculate equilibrium price and equilibrium quantity, okay? So this is how to calculate these two. That's one thing you should be able to do. The second thing is you should be able to calculate maximum willingness to pay and minimum willingness to supply. Let me show you how that's done, and I'm going to erase a little bit of what I wrote here, but that's okay. You can pause at any time. Layer is invisible. Oh, there you go. Okay. Okay, let me remove this. Okay, so guys, have a look. If I take this drawing again, the maximum willingness to pay is basically, oh, wow, what's this? Interesting. Oh, it's a calligraphy pen. That explains. There we go. What am I doing? Help. There we go. So this here, if I'm not erasing, this point here is the maximum willingness to pay. And that's a little bit of a strange name because this is basically the price against which Q equals 0 or QD equals 0 basically. So people are not actually buying anything, but from this price on and downwards means people are going to buy. Well, QD is 0, okay? And the same goes here for the minimum willingness to pay. To supply, excuse me, this is supply, and this is the maximum willingness to pay. or to demand, or so to say. Um, this is basically the point where a certain P leads to supply being zero, and from this point onwards, businesses are going to supply. So if I was going to take this layer again that I have here, uh, wait, what am I doing? Oh well, there we go. There we go. If I was going to take this layer again, if I'm going to find out when this is zero, all I have to do, this is then the, if QD is zero, that's the maximum willingness to pay. This would be then 0 equals minus 0.2 p plus 6. And then p, obviously, if you're going to follow this all the way through, plus 0.2 p on both sides. So this is then plus 0.2 p plus 0.2 p. Well, let me write it all out for you anyway then. 0.2 p equals 6, and then 6 divided by 0.2 equals p, and that's 30. Okay, so from the price of 30 or lower, that's when people are going to buy. If QS is 0, I should have done this the other way around, excuse me. If QS was 0, then 0 equals 0.3p minus 1.5. Um, then, I want this on the other side then, so it's 0 minus 0.3p equals minus 1.5, and then minus 1.5 divided by 0.3 equals p, and that's in this scenario then 5, if I'm not mistaken. So only from a price of 5 and onwards are businesses going to supply. That's what this says. So only from this price businesses are going to supply. Let me get another color then. Only from this price businesses are going to supply, and this is when consumers are going to purchase things, okay, or buy things. Then my question on the test would be, for example, well, why doesn't the supply curve start at 0 then? The answer is actually quite simple. Businesses are not going to offer products for €0 because they always have, um, well, between here and there are probably some what we call fixed costs. Okay, vaste kosten, constante kosten. So before businesses are actually going to offer products, they want to be sure that they're going to be able to cover, well, for example, their wages. A lot of things here are operational expenses, as you've learned in the previous chapter. So wages, the electricity bills, um, the rent is going to be paid, water bills are going to be paid, well, what have you, whatever. Um, so this is basically the most important stuff, and if you're not going to do this correct on the test, then I can guarantee that it's going to be an insufficient grade. So make sure to master this, okay? It's not too difficult at all, so you should be fine. Good luck, guys. See you next time.